Assalamualaikum and hi everyone. So for this video, kita akan cover subtopic 4.4 Intermolecular Forces of Attraction. And here are the learning outcomes. So, untuk Intermolecular Forces ataupun IMF, okay, ada dua bahagian. The first one is Wonderwall Forces and the second part is about hydrogen bond. Okay, so Wonderwall Forces pula boleh dibahagikan kepada dua. The first one is dipole-dipole ataupun permanent dipole. And the second one is London Forces ataupun dispersion forces. Okay, so let's have a look at the intermolecular forces dulu. Apa maksud intermolecular forces? So, from the wording itself, inter means intermolecule. Inter means between, intermolecular between molecules. So, let's say you have, sebelum ni kita dah belajar about covalent bond and also ionic bond. So, dalam molekul, contoh H2O, okay, ini kita panggil sebagai covalent bond. So, ini dalam satu molekul. So, between one molecule of water with another H2O. Okay, so akan ada forces of attraction dekat tengah ni. So, ini yang kita panggil sebagai intermolecular forces of attraction. Okay, so since kita dah belajar before this covalent and ionic bond, so of course lah, sebab dia dalam molekul, so of course these two yang lagi kuat compared to IMF. Okay, so the strength of IMF is responsible for the physical properties of the molecule. So physical properties, contohnya apa? Boiling point, melting point, and also solubility. Okay, so kita akan tengok two type of IMF. As I mentioned before, kita ada Wonderwall Forces and also hydrogen bond. Okay. Alright. So, the strength of IMF, as I mentioned before, it is responsible for the physical properties. Okay, so let's say kita ada kat sini contoh HCl. One molecule of HCl with another molecule of HCl. So dekat tengah-tengah ni between two molecule kita ada IMF, Intermolecular Forces of Attraction. Okay, so covalent bond dalam satu molecule ni of course lah strong. Okay, but between molecule ni kita ada intermolecular forces. So intermolecular forces apa yang ada dekat sini? Right, so let's have a look at Wonderwall Forces. So Wonderwall Forces, as I mentioned to you, can be divided into two. The first one is dipole-dipole forces, or the other name is permanent dipole forces. Permanent dipole, as I mentioned to you before this in our last session Google Meet, dia mesti ada dipole moment. Permanent dipole, barulah dia boleh dikategori sebagai dipole-dipole forces. Alright, so the next one is London dispersion forces ataupun boleh tulis London forces ataupun boleh tulis dispersion forces. It is categorized as temporary dipole forces. Okay, ini pun Mr. explain dalam our last session Google Meet. Okay, so siapa yang terlepas, you guys pergi tengok balik recording. Miss dah kenalkan dekat kamu apa itu IMF. Okay, and I explain to you in detail setiap jenis intermolecular forces. Okay, so as a recap, okay, kita tengok balik. The weakest is London forces, followed by dipole-dipole forces, and the strongest IMF adalah hydrogen bond. So IMF tadi kita comparekan tiga-tiga ni, the strongest is always hydrogen bonding. Okay, and then followed by dipole-dipole. Dipole-dipole sebab dia ada permanent dipole, it is fixed. Okay, so kalau London dispersion forces pula dia bersifat temporary, sementara. So that is why it is the weakest IMF. Alright, so untuk dipole-dipole forces, syarat dia mesti polar molecule. Okay, so contoh polar molecule, the simplest one is HCl. Kamu boleh nampak HCl. So H adalah partially positive, Cl partially negative. So ada permanent dipole moment here. Okay, so you can categorize HCl ini sebagai dia ada dipole forces. Next, let's have a look at London dispersion forces. So, take note that London dispersion forces ataupun London forces ini, it exists in all atom and all molecule. Okay, semua atom ada London forces and semua molekul akan ada London forces. Okay, because dia bersifat temporary. Okay, so for this video, I want to focus about Wonderwall Forces and the factors affecting the Wonderwall Forces. So, kita akan tengok into these 3 factors and dia mesti ikut turutan. So, the first thing first yang kita akan consider adalah dia punya size. So, macam mana kita nak tengok size? Kita akan refer kepada dia punya molar mass ataupun molecular mass. Okay, first kita compare dia punya size in terms of dia punya molar mass. And then kita compare dia punya molecular shape. Okay, so sama ada shape dia jenis memanjang, okay, straight chain ataupun branch. Okay, depends lah. Okay, nanti Miss akan discuss in detail after this. And last, kalau lah shape pun almost similar, barulah kita akan tengok polarity of the molecule. Okay, so the apa effect dia? Macam yang kita dah discuss before this, strength of IMF akan menentukan dia punya physical properties. Okay, so if the stronger the IMF, intermolecular forces, so maksudnya you need more energy to overcome the forces. Okay, you need more energy maksudnya in terms of contoh heat. Okay, so you need more energy to overcome ataupun to break the intermolecular forces. That is why it will result in higher boiling point. Okay, so first kita tengok molecular size. So the larger the molecular size, the more the number of electron yang ada. That is why the more distance over which they can move, right? So larger temporary dipole in the molecule. So first kita nak tengok the first factor which is molecular size. So molecular size ni kita akan refer kepada dia punya molar mass, and the greater the number of electron means the molecular weight also increase. Okay, so from there we know that the strength of Wonderwall forces will also increases because there's more electron in there and more energy needed. Okay, in terms of heat, you need more energy to overcome the forces of attraction. That is why, contoh kalau kita tengok kat sini ada CH4 dengan C4H10. So CH4 molar mass dia adalah 16 gram per mole, C4H10 58 gram per mole. So you can see here boiling point untuk CH4 112.15 Kelvin, and untuk C4H10 lebih tinggi, higher, 273.15 Kelvin. So maksudnya the greater, the higher the molar mass. Okay, kalau molar mass lebih tinggi means you need more energy, okay, to overcome the forces of attraction. That is why it will result in higher boiling point. Okay, so boleh nampakkan relationship dia, molar mass dia tinggi. Okay, you need more heat, more energy to overcome the forces of attraction, and that is why it will result in higher in boiling point. So next kita tengok molecular shape. Right, so molecular shape ni normally kita akan discuss dalam SEM 2 semester 2, and mostly melibatkan organic compound nantilah kamu akan belajar. So shape ni macam yang Miss cakap sebelum ni, okay, dia melibatkan long straight chain yang jenis linear ataupun yang jenis branching. Okay, yang bercabang. Alright, so kalau kamu tengok dalam 3D, in 3D, so long chain dengan branch molecule, okay, shape dia bentuknya berbeza. Okay, so ini kita kaitkan dengan surface area in contact. Surface area in contact. Okay, between the straight chain molecule is greater. Okay, so that is why for straight chain molecule ataupun linear molecule, okay, the strength of Wonderwall forces increases. Okay, so ini untuk shape kita akan compare sama ada dia straight chain jenis linear ataupun branch. And then kalau straight chain means there are more forces of attraction. Contohnya, okay, so ini analogi mudah lah. So let's say ini adalah shape, okay, rectangle with another rectangle. Okay, so dekat tengah ni adalah dia punya intermolecular forces. Okay, compared with square, segi empat sama. Okay, so let's say tengah ni adalah dia punya intermolecular forces. Okay, so kamu dah compare size. Okay, let's say size of the molecule similar. So you can't decide which one has the higher boiling point and so on. So kita akan tengok the next factor, which is dia punya shape. Okay, so bila tengok dekat shape, kita akan compare sama ada dia dalam bentuk linear. Contoh ini linear. And this one, let's say dia dalam keadaan branching. Okay, so in general, so kalau kamu imagine rectangle dengan square, so which one will have the more total surface area in contact? Sebab kita nak cakap tentang intermolecular forces of attraction. Maksudnya forces of attraction between molecule. Let's say ini satu molecule with another molecule. Okay, so of course yang memanjang begini, okay, ada lebih surface area in contact lah between one molecule with another molecule compared to yang compact. Okay, yang lebih compact size-nya begini, right? So let's have a look at example with, okay, I have here, let's say, formula, molecular formula dia both adalah C4H10. Okay, but C4H10 ni kalau kita draw out the structure, dia boleh jadi butane. Okay, macam ni, straight chain memanjang. You have C4, H pun ada 10. So ini adalah structure of butane. And kalau kita jadikan dia branch, okay, so this is the branch structure of C4H10. So this is called as 2-methylpropane. Masih lagi 4 karbon dan 10 hydrogen. Okay, so in this case when we have same ataupun similar molar mass, so kita kena tengok the next factor, which is dia punya shape. So butane dia tersusun dalam keadaan memanjang begini, and untuk 2-methylpropane it is branch structure. So you can see here untuk butane with another butane, dia punya surface area in contact is larger compared to 2-methylpropane. Okay, so the explanation will be, okay, which one will has the higher boiling point? Yang ada lebih banyak surface area in contact lah. Okay, you imagine you nak leraikan, you nak break these forces. Okay, so dia sangat-sangat kuat. So you need more energy ataupun more heat to break this ataupun to overcome these intermolecular forces. Let's have a look at the explanation. So if you compare butane and also 2-methylpropane, so butane will has higher boiling point. Why? Because the surface area in contact for butane is larger than 2-methyl propane di sini. Okay, boleh nampak perbezaan dia. Thus, butane will has stronger dispersion forces compared to 2-methyl propane. So let's have a look at the next factor, which is polarity of molecule. So untuk polarity of molecule, kita perlu consider lepas contoh kita dah tengok size dia almost similar, tak boleh. And then kita tengok factor shape pula. So let's say shape dia both adalah tetrahedral, tak boleh juga consider. So barulah kita consider dia factor polarity. So untuk factor polarity ni, normally dia akan bagi example two molecule with almost similar ataupun comparable weight, maksudnya tak lari jauh sangat dia punya molar mass. And let's say normally dia akan bagi non-polar and also polar molecule lah, lagi satu untuk kamu compare. So for polar molecule, it will have higher boiling point. Okay, why? This is because of the existence of dipole-dipole forces ataupun dipole-dipole interaction. Okay, so remember, dipole-dipole stronger than London forces. Okay, so the larger differences in the electronegativity means it will be more polar. The strength of Wonderwall forces, okay, increases. So means you need more energy to overcome the forces. Okay, ni mesti tulis to overcome forces of attraction. That is why dia punya boiling point higher in polar molecule compared to non-polar. Okay, so now let's have a look at this example. Let's say kita ada CH3, ini adalah ethane, okay, and also CH3F, fluoromethane. Okay, so untuk both molecule here, the molar mass is almost similar, 130 gram per mole, another one is 34 gram per mole, maksudnya hampir dekat lah. But the difference here, okay, ethane adalah non-polar. Okay, so for fluoromethane, it is a polar molecule. Okay, so dekat sini barulah kita boleh compare factor polarity. Okay, because dia punya molar mass almost the same and dia punya shape pun almost similar. Okay, so you can see here untuk ethane, dia punya boiling point is 184.5, and untuk fluoromethane 194.7 Kelvin. Okay, so this one is slightly higher. Why? Because of the polarity of the molecule here. Okay, so the explanation will be ethane is a non-polar molecule, so it only has weak London forces. Okay, so remember, bila kita compare mesti tengok balik this three intermolecular forces and tengok dia punya ranking. Hydrogen bond kalau ada, dia strongest. So next followed by dipole-dipole, and the weakest is London dispersion forces. Untuk fluoromethane, it is a polar molecule, therefore it has dipole-dipole forces. And dipole-dipole forces is stronger than London forces. That is why fluoromethane, okay, CH3F, has higher boiling point than ethane. Okay, so itu cara kita nak explain.